All right, class, the next thing I want to talk about is special types of factoring. The first one's going to be the difference of two squares. So if I have two real numbers or algebraic expressions and I have a squared minus b squared, this will factor as a plus b times a minus b. Okay? So in other words, the difference of two squares, the difference of the squares of two terms factors is the product of a sum and a difference, right? Sum being add, difference being subtract, of those terms. Now, what if I didn't remember this rule? Well, we can still use our old way of finding the factors of AC that add up to B, but in this case, our B would be 0. So let me show you how we could do that. So I have x squared plus 0x minus 36. Now, in this case, my A, capital A, is x. My capital B is going to be the square root of 36, which is 6. So this should factor to x plus 6, x minus 6, a sum and a difference. Well, I can go ahead and factor this the old way if you want by finding the factors of AC that add up to B. In this case, B is 0. We used a placeholder. So, what are some factors of negative 36? Well, I could have negative 6 times 6. All right, awesome. So I can go ahead and factor this. I have x minus 6, x plus 6x minus 36, and then I can factor by grouping. And I would get, if I collect my greatest common factors, x plus 6, x minus 6. See, I got the exact same factor. Next, why don't we go ahead and factor 4a squared minus 64. So the first thing I want to do is pull out the greatest common factor, 4a squared minus 16. In this case, my capital A is little a, and my b is the square root of 16, which is 4. So I have a plus 4 times a minus 4. I can also have the sum or difference of cubes. Unfortunately, these are the two rules, not unfortunately, but these are the two rules you're going to have to memorize. You need to memorize these rules. Okay? So if I have the sum of two cubes, a cubed plus b cubed, that's going to factor to a plus b times a squared minus a squared b plus b squared. Okay? So how do I know that that works? Well, why don't I go ahead and multiply these together so I can show you what we'll get. So if I have a plus b, I'm switching it to lowercase, times a squared minus ab plus b squared, and I go ahead and factor, I'm going to get a cubed minus a squared b plus ab squared, then I'll have a squared b minus ab squared plus b cubed. And as you can see, these terms are going to cancel out, and I'm left with a cubed plus b cubed. So when we're given something that we think is the sum or the difference of two cubes, we need to identify what are the cube roots. So in this case, my capital A would be x, and my capital B would be the cube root of 27, which is 3. So x squared plus 27 would factor as x plus 3 times x squared minus ab, in this case, is 3x plus 9. And then, because I've got a trinomial here, I would need to see if I could factor it any further. Now, are there any factors of 9 that add up to negative 3? No. So this is prime, and we can't factor it any further. Next, I have 3x cubed minus 24. Again, first thing I got to do, pull out a factor of 3, because we need to pull out the greatest common factor. So now I have x cubed minus 8. So in this case, my a is x, and my b is 2. And this time we have to use the equation for a difference. So I've got 3, because I don't forget my greatest common factor, x minus 2 times x squared plus 2x plus 4. And then I need to look and see, okay, are there any factors of 4 that add up to 2? And the answer is no, so we can't factor any further, and this is fully simplified. You can also factor perfect square trinomials using this shortcut, such as a squared plus 2ab plus b squared equals a plus b squared, and a squared minus 2ab plus b equals a minus b squared. Or you could just factor this the old way, that's what I recommend, by finding the factors of AC that add up to b, right? So in this case, our a, you have to verify that it matches this rule, right? So our a would be x, and our b would be 3. So it's going to factor to x plus 3 squared, but only because I know this is 2 times a, which is x, times 3, which is b. So I would just go ahead and find the factors of AC that add up to b. You'll get the factors of 9 that add up to 6 are going to be 3 and 3. So I'd have x squared plus 3x plus 9. And then we'd go ahead and factor by grouping. To me, this is the easiest way. That way you don't have to memorize anything. You can always verify, because what if it wasn't? What if it didn't fit this perfect square option? I think that's where I would get easily tripped up. So we collect our greatest common factors. I've got x plus 3 times my binomial, and I can write that as x plus 3 squared. So when in doubt, find the factors of AC that add up to b. This is a shortcut, but I prefer doing it this way.